Hi, in this video I'm gonna explain about the experiment 4 that I carried out. So it's called varying training sample size. The goal of this experiment is to identify the impact of training data sample size on accuracy. So for this, we use the previous training data set from the previous experiment and randomly select 10% of the training data set and then train the model. So I will train 10% each time from 10, 20 until it reach 100 using the best tree model from the previous experiment, that is logistic regression, decision tree and Bernoulli naive Bayes. So for experiment 4, let me briefly explain about the code itself. So I use the while loop to make sure the training size increase at 10% every time. As you can see, the training size that I started was 10% and then increased 10% every single time. So as you can see over here, I used the training set from the previous experiment and then I split it, the training set to 10% at the first loop, and then I train the model and then make the prediction. So for this, we plan to do accuracy, precision, recall, advanced power, and the classification report. Due to 10 pages for the experiment documentation, so we decided to go with accuracy itself. So once the accuracy been identified, the training set will increase another 10% and goes to 20% and will run the loop again until the training size reach 100%. And then for now, let's go to the result. For the result, for the logic regression, the best performing model for all three models. But for this experiment, we are focusing on the subsample size. So for the highest accuracy achieved for logistic regression is 0.72641 at 70% training data sample size, and the lowest was achieved at 10% training data sample size with the accuracy of 0.72285. So this shows an increasing trend from 10% to 70% training data sample size, and also it just slightly dropped and have relatively consistent accuracy after that. So for the decision tree, it's the poorest performance model for all three. As I said before, we are gonna focus on the training data sample size. So for the highest accuracy for this decision tree is 0.63778 at 100% increment, and the lowest was recorded at 0.624785 at 20% training data sample size. So in this manner, as you can see, the larger the data set, the better the performance for decision tree. So let's move on to the next and the last model that I trained with different data sample size. So the highest accuracy for Bernoulli naive Bayes is 0.71042 at 50%, and the lowest accuracy was achieved at 10%, 0.7097. But unlike the other decision tree and logistic regression, Bernoulli Bayes is quite different. As you can see, the accuracy is almost consistent after it reached the 50 until the subsample of 100. The accuracy are almost similar. So in conclusion, the experiment highlights the importance of choosing the best training data sample size to achieve the best performance. So in conclusion, the best training data sample size is used the correct amount so we can get the optimal model's performance. Thank you very much.